Okay, so I want to go through how we do some of the basic Excel commands that you'll need to do the linear regression problems. And I'd like to start with um, the example that we didn't do in class, which was number 2. Let me just kind of open that up and take a look at that. Okay, so this is a problem where we're basically looking at the association between um, the rate at which people quit jobs and the rate of pay. Okay, so the quit rate here, this is our y value, our y variable. And the thing you want to ask always is, what is the x, what is the y? How do you tell? Okay, the x is the thing that predicts the y, right? So the basic mantra here is x predicts y. So the question here is, what's predicting what? Okay, so here you want to realize that the pay is predicting the quitting, which makes sense, right? It's not the other way around, okay? So that's what we want to look at. So this is going to be our y variable. This is going to be our x. And again, I'm going to give you the order in which they are in the data set. But nevertheless, you have to understand that because it's really in the spirit of what we're doing, understanding how we're predicting things, okay? The quit rate is the number of people who quit in 1 year per 100 employees. Okay, that's important to understand. And so we want to go ahead, we want to do some scatter plot analysis. Okay, so we're going to start, of course, by just doing a scatter plot. One thing it's good to do when you do Excel, especially on the exam, is blow everything up in the beginning. You don't want to have to stop every time and blow things up. So I'm going to blow the numbers up in the beginning. And I'm probably going to format things also, just so I get that out of the way. I don't have to keep doing it over and over again. I'm going to keep out the 4 decimal places here initially, just because it's useful sometimes. Okay, now we're ready. Go ahead, insert. One thing for you Mac users, this should be the same between Macs and PCs, but one thing I can tell you that is different is that if the Excel window is too small, notice here I have it full screen, but if the Excel window is too small, sometimes you won't see the scatter plot option when you go to insert. You'll see some other options, but you won't see scatter. Sometimes you'll see the scatter plot option, but you can't click on it. The icon's not active. So you want to make sure that the screen is at least halfway full. Okay. I click on scatter. I get that. I'm going to do a little bit of editing here real quick. Legend, more legend options. I'm going to move that inside. Maybe I didn't click on it all the way, huh? It didn't. It really didn't give it to me. Let's try it again. I clicked on it. And it's not letting me do it, so I'm just going to delete it. We don't really need it anyhow. Okay, one thing that's kind of useful when you do this sort of stuff is I'm obviously going to put in my trend line, regression line. In the Macs, again, this will be on the right-hand side rather than the left. Click on that. It's always number 9, though, in either one. And now let's see if I can put this inside. It should let me. Nope, for some reason it's not. So let's just take it out, period. Okay. One thing that's useful is you notice that Excel always plots the origin. Sometimes if you have data where the x or the y is very far from the origin, if you remember that cricket chirp problem, the temperatures are very large, okay? You can reformat the axis, and I'm going to actually do this here. It's very simple to do. You don't have to, but I'm going to. I'm going to click on the values on the x-axis. You notice there's a little bar indicating that they've been selected. I'm going to click Format Axis, and this can be used both on the Mac. Oh, I see why. I actually have 2 windows that are open. You can't see this. Let me drag it over. I have a second computer. That's why I'm not seeing the legends, because it's showing up on the other computer screen. Sorry about that. Whether you're using a Mac or PC, though, when you click on Axis, Format Axis, you're going to get some little GUI menu like this. I'm going to click on the minimum value. This tells me the minimum and the maximum value. I'm going to change that from 0 to around 4. Okay. And notice it moves the table in. Again, even though you don't have to do this, I'm going to change the size of the regression equation just because it's easier to see. And of course I would go back and I would edit the table. Okay, so I would first of all do the axis labels. Okay. Same with the y-axis. Most of you know this, but I'll just do this. I'd say number per 100 employees. Okay. Okay, so this gives me a pretty good table, and of course I would change this. To edit the title, all I have to do is click inside. Okay. And since I am dealing with a pay rate, I'm going to say USD per hour. Okay, that looks good. Again, you don't have to do a lot of this formatting, but you can. It looks nice, makes it easier to read. Okay, the main questions I want to answer then is I want to know, is it linear? And I would say it does appear linear. There's no outliers that are detected. And I'm going to compute the R value because I want to know the strength of the association. I'm going to do this off to the side again because I want to be careful and not have any problems when I do Control-Shift-Down key. Although I'm not going to do it on this particular problem. But you will on others. And choose any one of the columns, X or Y, it doesn't matter which one you choose first. Correlation coefficient's the same. Hit enter, and I can see what the picture's already telling me basically. It's saying that the correlation's pretty good. I wouldn't know that it's 0.85, but I'm not surprised. And it's negative. Okay, so based on this, I would say that there's a very strong negative correlation. And again, the words very strong, those are reserved words because the magnitude of the correlation is between 0.8 and 1. Okay? All right. So that's it for our chart here. Okay, when we go on in the problem, it says, the next part of the problem then goes ahead and says, suppose a mill employs 100 people at $7 an hour. And so I want to know how many people should the employer expect is going to quit in 1 year. For example, if you're doing hiring or whatever, you might want to know that. So I have to go ahead and compute the predicted value of y when x is equal to 7. This is my x value, right? Okay. So we go over to Excel. And again, I'm going to give you the regression table so you don't have to worry about that. I'm going to give you some columns between the regression table and this because you're going to want to make your predicted values and all that. But I go up to data, and again, you're not going to have to do this. And I already have everything selected. I did this problem earlier, so I can just go ahead and hit OK. And everything's there. Again, what your eye wants to go to and what I'm going to highlight and enlarge here are the statistics on the residual and the values of the slope and the y-intercept. Okay, that looks good. Okay, now I'm ready for the predicted value. I need the slope, the y-intercept and the slope to do that. Click on the y-intercept first, and I'm going to multiply the slope by 7, and that gives me my value. Okay, now one thing you should always do is you should check your predicted value versus the line. This value should be exactly the same as what's on the line. These are the same values, okay? Why? Because it's very easy to choose the intercept when you actually mean the slope and vice versa. And if you do, I guarantee you'll get very different answers, okay? Let me just show you what you would get. Suppose I hit the slope first. Then I hit the y-intercept times 7. Okay. Notice this, okay, this is the wrong value, okay? This is the y predicted at x equal to 7. This is the correct value. And this is the wrong value. How can I tell that? Well, I go to my table, right? I look at 7. I see the values around 2.5. Let's see, a little less than 2.5, and this is saying 33. So that tells me automatically I did something wrong. So always do these sort of self-consistent checks. Again, I will not accept as an excuse on the exam, oh, I just hit the wrong buttons. If it's up to you to be able to tell if a value is reasonable or not, if you made a mistake. You have to be able to go back and troubleshoot. It's a very important part of what we're trying to do here. Okay, so I'm convinced that's okay. That's great. What's the predicted value? Well, I'm going to go ahead and round up. If I'm a manager, right, 2.4, do I round it down or up? Well, I want to know what the maximum number they're going to quit. I'm asking this for a reason because I want to be able to plan, okay? So I'm going to have to assume that 3 are going to quit. I'm not going to round down. Okay. So that's the prediction question. Now the prediction interval. So this is a little tricky, and I want to go through this. So what is the question? The question is saying for that employer that we just talked about, okay, he has 100 workers and he's forecasting for 1 year. If he made no new hires during a 1-year period, what would be the maximum number of workers he would expect to have at the end of 1 year? Okay, so what am I doing? Well, I'm computing the prediction interval on the number of people who are going to quit. That's my y variable. So the minimum number that could quit will be the lower value of the prediction interval. Okay, this is the minimum that are going to quit, right? I'm computing this prediction interval, and the lower value tells me the minimum value I can have for the number of people who will quit. So the maximum he's going to have left is a number he started off with, which is 100, minus the minimum number he can expect to quit. Let's take a look at how to do this. Okay, so I'm going to have to go ahead. I'm going to have to compute the standard error here. So my standard error is the square root. Don't forget the square root. Gotta have it. It's the sum of squares residual divided by the residual degrees of freedom. Okay? Hit enter. And so the minimum number of people that are going to quit. Okay. This is going to be the predicted value of quit. Okay, this is going to be the predicted value minus 2 times the standard error. This is giving me the lower value of the prediction interval, right? So it's going to be equal to the predicted minus 2 times the standard error. Okay, so that's telling me that the minimum that can quit is 100. So the maximum I can have left is what I started off with minus the minimum who could quit. Okay, so this is starting number minus the minimum that could quit. I get 98.5. Now the question is, do I want to round that up or round that down? Again, if you're an employer, you always want to round that down. No such thing as a half a person, right? So here, the maximum number is going to be 98. Okay, so that's going to be my answer. Okay, what is the minimum number he could have left? Well, the minimum number he could have left would be the starting value minus the maximum who would quit. So the maximum number who would quit, this is the upper part of the prediction interval. So this is equal to the predicted value plus 2 times the standard error. Okay. So that's the maximum who are going to quit. In other words, it's the predicted plus 2 times the standard error. Okay. So the minimum he could have left would be the amount he started off with minus the maximum who could quit. So we started off with 100. I'm just going to format these cells a little bit here. And the maximum that could quit was this. And so the minimum I could have left, again, I'm going to round that down, okay? Because I can't think of it being a half a person. So when you're an employer, you're making a decision, you're planning for the worst case scenario, okay? So I want the minimum number. That's going to be 96, okay? So this kind of gives you an idea of what to do here. Now, I didn't ask this in this question, but obviously you're going to have to be able to analyze the residuals. So let's go ahead and do that. Let's make the residual plot while we're here and we're thinking of it. So for the residuals, I'm going to highlight this because I think it's kind of nice to see this and focus on this maybe. Dark blue is a good color that shows up pretty well. And we'll make that bold. Okay, so I'm going to start off with 3 columns. These are my x values. These are going to be my residuals. I want the residuals and the x next to each other because I want to make a scatter plot, right? And the last one is y predicted. Okay, so the x values are easy. I just cut and paste those. Now, when this happens, what this means is you didn't give enough room. Just move it over like that. Okay, the predicted values, I'm going to compute those using my coefficients now. Y-intercept plus the slope times the x value. And again, I'm going to have to anchor. I want to show you what happens if I don't anchor, okay? So you know what not to do. Notice I get some values because I actually computed stuff below that. Okay, so Excel's trying to use these values, but you're always going to have a tail of zeros at the end. You're never going to compute that many numbers. I can also see these numbers are really whacked, okay? I mean, I looked at the predicted, I looked at the true value. These aren't even in the same ballpark. So normally what I do real quick is I do a quick check. I look to make sure that these values are somewhat similar, or I can check the graph actually. If I do look at the graph, I'll see that when I'm down around 8, okay, the quit rate is roughly around 2. Then I'll check in the middle real quick. I'll just check to see if these values are the same. They aren't. I check at the end again. They're not even in the same ballpark. So since this value is correct, the other values are probably wrong. The most likely suspect is that I didn't anchor, and I go back and I didn't. When you anchor, I always start at the first value. I don't click. I just use the arrows to move over. This way you don't have any problems with accidentally putting your cursor in the wrong place. Okay. Now I click on that. I'll get the same value for this, of course, and Excel's not happy with something. Because I put my thing in the wrong place. I need this $sign over here. And this should be a 17. Here we go. Okay, that looks good. Pull it down. And it looks good. I do a real quick check again. The data value of y is 2. The predicted 1.8. I believe that. This is 0.5, 0.25, 2. Okay, it looks pretty good. Now I'm ready for the residuals, which we remember is the data value minus the predicted. Okay, so I'm going to go ahead and put that in. Click on the data value, subtract it from the predicted. Okay, and I get this. Just pull it down. No anchors needed. And now I can do my scatter plot. I'm gonna plot the residuals versus x, regular scatter plot, and I look at the data. And here I'm not going to be too picky about the labels. Okay, the labels aren't really that necessary. We're just really looking at the residuals. I'm going to format the axis again real quickly just because to make it a little easier to do the analysis. You don't have to. And I look at two things now, right? The first thing I look at is I look at the scatter of the plots around points around 0. These appeared pretty well distributed around 0. Now you might say, well, there's a bunch up here, and there's a bunch down here, and then a bunch up here. You have to be a little careful. What we're actually looking for is a systematic trend. Okay, nothing, and we're going to talk about this on Monday actually, nothing is usually totally random. In fact, this is how in real life they catch people who are trying to commit fraud. Okay, they try to make things look random. Even in randomness, there's patterns. But what I don't see, what I'm looking for, is a pattern like these are tracing out some function. Okay, they're going down, or there's kind of going down and up. I don't really see any strong evidence for that. Okay, so I'm going to say here that these appear relatively well distributed. The other thing I'm looking for again is I'm looking to see if the variance is relatively well distributed. In other words, do the deviations appear about the same at the beginning and the end? And again, I would say pretty much they are. I mean, you might want to argue that there's a dip here, but it really isn't that significant. And if I usually see it, it's usually going to be some sort of trend where you're going from higher to lower or lower to higher. I don't see that. This data point's at the end, it's pretty high. This is at the end, it's pretty high. There's really not enough data points out here to really say anything about what's going on here. Okay, so I would say I'd be cautious, but I would say that the model appears okay. I don't really see anything that would disqualify it based on the residuals. Okay, and that's about all you really have to do. Again, most of these commands on the Mac and on the PC are going to be about the same because I'm going to give you the residual table. So that shouldn't be a problem. And we'll go through this more on Tuesday when we have our review session. Monday we're going to go through chapters 11 and 12, so we're not going to cover any more of this in class. But of course, if you have any questions, always feel free to ask me. Okay, thank you.